We were talking about chloride deficiency in durum wheat. What do we know about it? What damage is occurring, and what might we do about it? So straight up with the take-home messages in case I don't get to them by the end. First of all, we identified chloride deficiency in 2008 and in Australia, and we also found that there had been a lot of US work done in the past. We did some trials in 2008 and 2009 in the field, and we found no yield response to chloride fertiliser in those trials. So in funding parlance, the issue was a bit of a dead duck, so consequently there was no specific trials on it last year, but then started getting a few calls from advisors saying that we got these symptoms of chloride deficiency out there, and as it turns out, it seems that the symptoms are being exacerbated by last year's wet conditions. Another take-home is that of the current commercial durum varieties, Jandroy seems to be more sensitive to chloride deficiency than Caparoi, which is more sensitive than Belleroy. And the last take-home message, I think, is that there is hope for the future. There's improved sensitivity in some of the elite breeding lines that are coming through. I guess to wrap it all up, chloride deficiency is very highly season specific and variety specific. So first of all, what do we know about it? As I said, we've had this issue around for a few years. Symptoms were first noticed with the release of Jandroy, and here's a photo from a few years ago, 2007, showing a difference between Jandroy and Belleroy in a farmer's crop. And another close-up of the spotting symptoms. Can I point this somewhere else? So straight away we did a bit of literature searching and found that there had been quite a lot of work done on this issue in the USA, and that it seemed to be chloride deficiency. A fellow called Rick Engel at Montana State University has done probably some of the best work on it. And you can see in the photo there some clear differences in field trials where chloride has or has not been added. What else do we know? Again, when we started in 2008, we did leaf tissue testing, and I did a glasshouse trial as well. What we found in the glasshouse, where we grew a range of different varieties in sand culture solutions, was that the spots first appeared around about a month before flowering. Up till then, all of the plants seemed fine, even those that we gave absolutely no chloride to. And as the symptoms rapidly progressed up the plant from the bottom, and ends up with the sort of leaf symptoms that you can see in the bottom of that half of that picture. And then quickly the affected plants were completely covered, and the lower leaves ended up dying on the most severely affected plants. We also found that where we didn't add any chloride to the plant, the plants ended up with less biomass, and they flowered up to a week later. And deficient plants also had reduced seed weights, and that was not only in durums, we found that in some of the bread wheats that we grew as well. So I presented all this stuff 2 years ago now, so this is just a quick recap. And we had no field response to chloride fertiliser additions in the field. And there's a picture of our nice field site, 2008. 2009, so this is a bit of data that was not been presented yet. So we had a combination of another small plot trial on one farm where we were looking at rate response. We had a whole range of rates. We were looking to score the spots, looking at the plant chloride tissue concentrations, the biomass and the greenness, yield, quality, all of the things we could think to measure. We also did some of these on 5 different large plot trials across the Liverpool Plains, and as a result, that what we found basically, first of all, when we looked at chloride in the soil, we did soil sampling at all of these trial sites. We found that the soil chloride really wasn't low enough to get consistent results. And here is some soil profiles from our one small plot site and then 5 large plot sites. The red and the yellow zone I've drawn in based on the guidelines that they have in the US for where Red is where you're almost certain to get a response to chloride fertiliser, and yellow you might get a response. So, and their guidelines are based on the top 60 centimetres of the soil profile. So you can see when we compare our data with those, there was really only one or two that were only just in the possible yield response area, and all the rest were above that, and some of them had quite a lot with depth. So as a result of that, when we looked at the soil chloride profile, soil chloride concentrations in the plant, we harvested the whole plant at early head emergence, which is the same time that they'd calibrated this work for in the US. We found that these were the percentages of chloride in the plant. So the two that we probably had the lowest amount of soil chloride were 0.11% in the plant, and that's only just above the 0.1%, which is again a US guideline for where you're likely to get fertiliser response. Between 0.1 and 0.4, you may possibly get a fertiliser response. So we had two more trials in that zone, but these two we had clearly plenty of chloride. So as a result of that, there wasn't really all that much leaf spotting in those trials in 2009. What we did find where we were adding the chloride fertiliser, it did increase the amount of chloride in the plant, but you couldn't actually measure that until that head emergence stage, early flowering. And these are the results that we got. This is the amount of chloride we put on in that rate trial, and as you can see, the more chloride we put on, we ended up with more chloride in the whole plant. So we started out at that 0.11%. And we added chloride both as a solid product and also as a liquid, and there's basically no difference to how you add it. The plant will take it up relatively easily, except for this one here, and the only difference there was we added it in stages, and that one, that last stage was obviously added a bit late to be picked up by this sampling. We did actually sample all of the plants at an earlier stage when you'd normally do your plant tissue testing, and we found none of these relationships and no apparent low chlorides in the plants. We did find that adding chloride did decrease the leaf spotting, even though we didn't have much leaf spotting. It did actually decrease it a little at the small plot site, but it didn't affect the grain yield or the grain quality in any of those trials. There is a chart in the paper there where you can see the effect of decreasing leaf spotting. It was a measurable effect, but it wasn't really a major one. So not a great deal happened. The excitement faded until last year when, as I said, with the wet conditions, a few people were ringing me up and saying, look, we seem to have a fair bit of this around. By coincidence, 2 of the 5 Durum breeder trial sites, their variety trials turned out to be on sites that obviously low in chloride. And so the breeder, who's Bert Collard, or was Bert Collard, he's since just left the department. He went out and scored all of his sites, and we did some plant tissue testing as well. So basically 2010 we had a wet profile at sowing, and then we had good in-crop rain, which kept the plants fairly shallow rooted. Quite possibly also would have leached some of the chloride that was in the topsoil down, but keeping the roots near the surface is generally where, if you remember back to those soil profile charts, soil tends to be lower in chloride near the surface anyway, easily leached. Probably there's a bit more Jandroi being grown, which is a more susceptible species. So he's noted these symptoms at Tamworth and Currabubula trial sites, and he's gone out and scored the leaf damage. Also did some scanning of greenness with the green seeker, and also done some digital photo analysis as well, but that was only at Tamworth. So his results, and this chart's in the paper, but this is the results of his scoring system where he's gone nil up to extreme, and that's the percentage there is the percentage sort of leaf damage of the top couple of leaves. And here are your commercial varieties, Belleroy, Caparoi and Jandroi. And so you can see that the Jandroi was basically scoring almost to the extreme, whereas the Belleroy was the better performer of those three in the moderate sort of zone. And then here are the some of the pre-release lines from the New South Wales breeding program, and you can see there's a huge range. Probably should add that there's 2 bars in the chart. The yellow bar is from the Currabubula score, the darker one is from the Tamworth score. You can see some of them there's a pretty big difference. Now those guys didn't actually do any soil testing, but you know, based on our previous experience, we'd probably suspect that the Currabubula site was a bit more deficient in chloride than the Tamworth one, so that may be why it's showing up more. Higher for some of those varieties. There's a couple worthy of note there. These 3 lines here are relatively low scoring. This one here, 240, 578, had a low score but a better yield than Jandaroy, whereas these 2 had a lower score than Jandaroy and equal yield. In the same trial, they also have a number of varieties from the South Australian breeding program, and one of these in particular, first of all, as you can see, again, there's a range. Some of those had more spots on. For some reason, they seem to be possibly a bit higher or equal as in Tamworth than they were in Currabubula. Can't explain that one. This particular one here, SA9096, had not only the lowest spot scoring, but also had the highest grain yield, so it's got good prospects. This is the grain yield diagram. Again, those 3 locally bred varieties and this South Australian one, it was higher than any other variety at the Tamworth trial only. I should mention the Currabubula trial wasn't able to be harvested. So summarising that, we did. Sorry, I'll go back one. We did do plant testing across the Tamworth trial, and we found that the average plant chloride was 0.14. Remember, 0.10 is sort of like a critical level. Big range, between 0.05 up to 0.29, but there was no variety differences at all in that trial. So they're all low, basically. They all had the same sort of pressure of a low amount of chloride supplied, and they just had to see how they performed. And this SA096 or 9096, I think I might have cut some out of there, yielded the best, had least leaf damage, and was also well related with the highest greenness. And then, yeah, those other 3 that I've mentioned from the New South Wales breeding program, one yielded well, low leaf spotting, the other ones were better than Jandaroy in yield and better in leaf spotting. So to conclude, chloride deficiency, very highly season specific and variety specific. Based on the results that we got from 2008, 2009 field trials of actually adding chloride fertiliser, we can't actually give any recommendations in terms of, you put this, if you think you've got a problem, put some chloride fertiliser on and you'll get some payback in terms of yield, because we just didn't get that data. Had we done some of those trials last year, we may well have had that information, but that's as chance dictated. But I guess the bright light on the horizon is there is potential for breeding to reduce those spotting symptoms in new varieties, as well as maintaining or increasing yields. Thank you. Durum seems to be the biggest sucker for producing the leaf spotting symptoms. When I did the glasshouse trial, I had 5 Durums and 5 bread wheats. All of the Durums had the leaf spotting symptoms to some degree. It was a very extreme situation because I gave them absolutely no chloride and they were grown in sand. The bread wheats, some of them developed a small amount of spotting. Some of them actually developed some other symptoms, which were really, really weird looking, in that, in fact, if you look up the symptoms book, 2 of them actually developed symptoms that you would swear were copper deficiency. We leaf tested those, and they weren't deficient in copper, and they were deficient in chloride. So the leaf tips of some of the younger leaves sort of really curled up and withered. So. But it's been well known in the US research. They were actually looking at chloride responses to fertiliser in bread wheats for many years before they noticed any spots. or there was any talk of spots, because it was all only really happening in the Durum. And that's sort of two schools of research happening in parallel.